Hello everyone, welcome back to the Gate Engineering online learning classes. In the series of digital electronics, today we are going to learn about signed binary number and one's complement and two's complement of the signed number with the help of a numerical problem. Let me first discuss about the signed binary number and how we can represent any negative number in the binary form. Because computer understand only language of binary, that is 0 and 1. Computer and microprocessor does not understand what is positive, what is negative. That can be only identified with the help of binary representation. So as here you can see in this table, we have given a number like positive 3 we have given. So the number is 0, 0, 1, 1. But if we have minus 3, it is given as 1, 0, 1, 1. So you understand in this way that 3 is the decimal number and its binary representation in 4-bit is 0, 0, 1, 1. Binary representation in 4-bit is 0, 0, 1, 1. This is for unsigned binary number. If we talk about plus 3, this is signed binary number which is positive. So we can write it as again 0, 0, 1, 1. So in this plus 3, 3 bits are the magnitude. 0, 1, 1 are representing to the magnitude of the number. And this most significant bit, that is called left side bit, leftmost bit or most significant bit, which has more weightage, is representing to the sign bit, represented to the sign number. So plus sign is represented by 0 in the binary and minus sign is represented by 1 in the binary. So here plus 3 is nothing but 0, which is indicating to the positive sign, and 0, 1, 1 is indicating to the magnitude. We talk about the minus 3. Minus 3, negative will be represented by the 1 and 3 will be represented by 0, 1, 1. Similarly, here we can see plus 6. 6 magnitude is 1, 1, 0 and positive is with the 0. And minus 6 magnitude is 1, sorry, sign is 1, which is indicating to the 1, indicating to the negative sign, and 1, 1, 0 is the magnitude of the number. 1, 1, 0 is representing to the 6 and leftmost bit 1 is representing to the negative number. Similar way, here we can see another example like triple 1 is the 7 and 0 is the positive. Here triple 1 is the 7 and 1 is the negative. So this is indicating to the minus 7 and this number is indicating to the plus 7. Now we talk about the ones complement and two's complement of the signed number. So always remember, for positive signed number or positive signed number, signed magnitude is same as the ones complement is same as the two's complement. If any number is given, let's see plus 5. Plus 5 can be written as first in the signed magnitude, which is 1, 0, 1, and plus will be indicated by the 0 as we have already seen. 0, 1, 0, 1 is the plus sign, plus 5 in the signed magnitude, and this is also same as the ones complement and this is also same as the two's complement. So 0, 1, 0, 1 is representing to the plus 5 in all the representation like signed magnitude, ones complement and two's complement. And if we talk about the minus 5, signed representation is 1, 1, 0, 1. This 1, 0, 1 is 5 and this one is the negative. So 1, 1, 0, 1. Okay, so this is in the signed bit. Now if we write this in the ones complement, we need to take the ones complement of the magnitude and signed bit will be the same. So it will be 1, 0, 1, 0 is the ones complement of 1, 0, 1. So this is the representation in the ones complement form. To write the number minus 5 in 2's complement form, we'll take the 2's complement of 1, 1, 0, 1. So first of all 1 is the signed bit which will be the same as the signed complement, 1's complement as well as the signed magnitude. Now 2's complement of 1, 0, 1 is 0, 1, 1. So this is the representation in the 2's complement form. So here we can see we have taken the plus 5. So plus 5 is nothing but 0, 1, 0, 1. 0, 1, 0, 1 is 5 in the signed magnitude, it is 5 in the ones complement, 5 in the signed 2's complement. But if you are talking about the minus 5, here you can see minus 5 is 1, 1, 0, 1 in signed magnitude. This is the 1's complement. Minus 5 is here and its binary representation is 1010. So in the 1's complement, minus 5 is represented by 1010 and 2's complement form minus 5 is given here and its binary representation is 1011. So 1011 is representing to the minus 5 in the 2's complement form. 1010 is represented to the 1's complement form to the minus 5 and 1101 is the sign magnitude is represented to the minus 5. Let me take one more example here. We need to represent minus 25 as an 8-bit sign magnitude, 1's complement and 2's complement. So first of all here number is minus 25 given in decimal, negative number. So we need to write the magnitude first. What is the magnitude of the 25? Magnitude of 25 is 11001. This is the simple conversion from decimal to binary. With the help of binary weights, we can write it very easily. So 16 plus 8 is 24 and plus 1 is 25. So this 11001 is represented to the 25. And we need to add extra 1 is for the sign bit. So this is the representation of minus 25 in signed magnitude. But how many bits do we have here? 6 bits. So we have total 6 bits now. But in questions we need to write the number in 8 bit. So write the 25 in the 8 bit. So how we can write the 25 in the 8 bit? We can write 25 in the 8 bit like 000110001. And this is the 25 in the 8 bit. We can read weights are high at 16, 8 and 1. So this is the number in 8 bit represented to the 25. But we need to write the minus 25. So MSB will be replaced by 1 to indicate the sign bit. So now we have number 1001101 is minus 25 in signed magnitude form. Here this one is sign bit and 0011101 is the magnitude. Let me now we need to write the same number in one's complement form. So in the one's complement form, sign bit will be the same as 1 because it is in the negative number. We will take the one's complement of magnitude of the signed number. So one's complement of 0011001 will be 110011. So how we have done? We have taken the ones complement of the number. It means toggling the bits. 0 is replaced by 1, 1 is replaced by 0. So we got this is the number in ones complement form representing to the minus 25. So now we'll write the number in two's complement form. For the same minus 25, sign bit is the same, which is 1, and we'll take the 2's complement of the signed magnitude number, that is 0011001. If we write the 2's complement of this, that is nothing but 1's complement plus 1. So here we can add 1 to get the 2's complement number. So it is 1100111 is the 2's complement representation of minus 25. Where leftmost bit is again its sign bit. I hope this is very clear to all of you. In this video, we discuss about the positive and negative number in signed magnitude form, one's complement form and two's complement form. In the next video, we will see arithmetic operation on signed binary number with the help of one's complement and two's complement. So to get the update about such kind of the video and understand the concept with the help of numerical problem, please subscribe the channel and share the videos with your friends also. Thank you so much for watching this video. I hope this will be helpful to all of you.